realize that, right? Okay, so let's go in and talk about that because we really need to understand those concepts. What exactly is a client and what exactly is a server? So, see, today I came prepared. I'll be surprised, if I run out for the rest of this year. Okay, so here is your computer. Okay, so let's say you have a little netbook computer here, and here is the internet, and this is the power server. Okay, the power server really does not have a body anymore. Can anyone guess why I said that? It is now virtualized. Okay, so the power server used to be an actual machine, that is just the power server itself. Now the power server is virtualized, which means it is a virtual machine on a fairly powerful platform. But the same physical platform is also the physical part of many other servers. Okay, so this is only one of the quote-unquote pretend servers on a real physical machine. But for this picture, we can just say that it is a box, just like that. Okay, so when you enter something, okay, let's say you want to look at all the student pages, so you type power.arc.losrios.edu, and then you press the enter key on the URL, on the address bar. What happens at that point? Okay, well, the first thing is, it will remember DNS, okay, remember domain name service. Okay, so the first thing it would do is to ask the DNS server and say, hey, my user wants to access a domain called power.arc.losrios.edu. Where can I find it? What is the IP address corresponding to this name? Because remember, all computers are identified by IP addresses. The name or the domain name is really something so that we can remember, a certain website more easily. Okay? So the first thing that we'll do that is behind your back that you cannot see is it will first query a DNS server and ask the information. The server will return and say, okay, the power server is 165.196.78.8. This is actually the IP address of the power server. That tells you something about how much I work with that particular server. So then your computer will then turn around and say, okay, I want to send a request to 165.196.78.8. So then it will go out to the internet, bounce around a little bit on the internet, and the request will arrive to the web server. The web server will look at your HTTP request and say, well, okay, what document am I going to reply back to the client? So we are already introducing the terms here. This is the client. Your computer running a browser is called the client in this particular arrangement. The computer that is storing the web pages and rendering the web pages is called the server. Okay? The terms may seem to be counterintuitive at first, but it does make sense. Whoever is initiating the request is the client. Whoever is responding to the request is called the server. In other words, the server is the one that is sitting around doing nothing for the most part until someone asks the server to do something. The client is the one that is actively doing something and say, I want this, I want that, and so on. Okay? So the server will basically look up the file system, look at the index page and whatnot, and when it finds what kind of document, or once it renders the document to send back, then it will reply back and say, here is the reply, and then the client will display it on the screen. Okay, or I should say it will render it on the screen, because what is actually transmitted is HTML. What you see on the screen is the rendering of HTML. So are we okay in terms of the terms? Whoever is sending the request is the client. Whoever is replying to the request is the server. How do these terms apply to P2P or peer-to-peer, like torrent? With torrent, every computer can potentially be both. Okay? So when you are, say, downloading the Knoppix, DVD image, which is one of the very few legit, stuff that you can download using torrent, because most people download stuff that is, illegal using torrent. So, but in that case, if your computer is a leech, then your computer can be both, because basically you're downloading files from other computers. You're making the request. You're saying, okay, I need chunks of this file. Who has this chunk? Who has this chunk? And who has this chunk? So the other computers who are feeding your computer are quote unquote the servers. But at the same time, guess what? Your computer can be a server too, because someone that is close to you in network terms can say, oh, you got some chunks already on that particular ISO image. Why don't you send me some of that stuff too? So your computer can be a server at the same time when it is also a client. So the torrent or the P2P concept is interesting because it turns computers into both clients as well as servers. Now, if you're kind enough and you have a lot of bandwidth to spare, after a while you will get the entire ISO image already. At that point, you are no longer a client because you're not requesting any more chunks from other computers. So at that point, as a seed, your computer becomes strictly a server because you're only responding to the clients and say, oh, you want chunk blah 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 of this file, I'll give it to you, and so on and so forth. Okay, so torrent and peer-to-peer technology is very interesting because of that particular perspective. Now, since we're talking about computer servers and computer clients, can we have any other examples in addition to HTML, stuff? What other types of services or resources do we need the client versus the server setup? Games, very good. Okay, games have clients and also servers. Can you describe, what would a client be doing in a game situation?
Like the actual game or on a technical side?
Well, just from the user's perspective, who is the client?
I am.
Okay, or your computer. Your computer running the game is the client. Who is the server? The publisher's website, right? The publisher's website, it will basically, have a server implementation. Why do we need a client-server arrangement in this case?
Because not all the files and stuff will be stored on your computer.
Okay, that's one. Want to add to it?
Updates or patches that you may need because your computer is crashing, you can ask the server before, and they can send you.
Okay. But that's not the main reason why we have a client-server setup in games. Yep.
You're interacting with other clients.
Exactly. Okay, that is the main reason. Even though the other reasons are also true, but the main reason why games have a client-to-server setup is so that your computer, acting as a client, can interact with other computers. In other words, in that particular situation, let's see, where's my pen? Oh, it's right here. Okay, I should probably attach that one to my neck too. Okay, so in this case, I'm not going to draw the internet anymore, the big old cloud. So in that case, we have a server. Okay, in reality, it may not be one single machine, but we will look at it as one single entity acting as the server. Okay, but in reality, that can be like multiple machines doing the same thing. So this is our server, and here we have a whole bunch of gamers. Okay. Gamers, and so on. The arrangement of this means that all these computers can connect to the server all at the same time. Okay, so computer A or client A, client B, and client C in this case can all be talking and interacting with the server at the same time. So if this player is shooting a certain weapon and it is aimed at this player here, then the event of shooting will go up here. The server will interpret the current location of the avatar in the game, realize that the avatar or the character of computer B is in the way of the projectile. It will give it the appropriate time delay because the projectile actually needs time to get to the target, But after a certain time delay, the server will say, okay, your character should be hit now. So it will trigger an event. So when computer B talks to the server again, it will get an update and say, oh, guess what? You are hit. Okay? Okay? And it doesn't have to be just, one actor, one character, affecting another character. If someone has a fragmentation grenade, okay, it can affect multiple users all at the same time. Okay? So that's why, in gaming, it is actually very important to have a server versus client type of setup. But why not having computer A to talk directly to computers B and C? I mean, why not using a peer-to-peer type of setup?
Well, you might not be able to talk to them because of the network.
Mm-hmm.
You're not in the local area.
Yep, it may block, all the traffic. And the second thing is, how do you find the other players? You need some sort of centralized, basically it's an address list of people who want to be in the game in order to find, people to even play with. Now, does this only apply to PC games?
No.
Consoles too. Consoles dating all the way back to maybe even the Dreamcast, had the ability to go online, even though it was really, really old at the time. How many people play Mario Kart Wii? Okay. Okay. Have you guys gone online and played with other people? Okay. Do you play with only people like, in the same apartment building or your neighbors? No. You race against whom? International, right? When you sign in to Mario Kart Wii, they go global. Okay, it will pick up people from Europe, it will pick up people from Japan, it will pick up people from Korea, it will pick up people from Australia, and so on and so forth. So now, when you're in a race, what is being updated? When your computer, when your Wii is talking to the Nintendo server, what is being transmitted? Shells. Shells, the gift boxes, and so on. Bananas, exactly. But what is being sent back from the other computer? The location, steering input, and all the other stuff of the other cars. Okay, so the other cars or bikes, the server will transmit that information back to your Wii so that your Wii can render the activity, the location, the orientation, the speed, and so on and so forth of the other vehicles in the game. Yep. No, torrent is peer-to-peer. This is definitely, client to server only. No, in this case, it is not a swarm. This is completely centralized. Everything goes to a centralized computer. Okay. Can someone point out some other applications of this, client versus, server setup? How about World of Warcraft? Yes, World of Warcraft has many other interesting aspects too. The animation of the characters. A lot of people spend a lot of time to customize the animation. They will make the characters, do the YMCA thing, amongst other things that I cannot talk in the class. So, I mean, some people just have way too much time on their hand. I mean, just,
Way too much.
Way too much. What about Facebook? Is Facebook like this, or is Facebook peer-to-peer? It's centralized, right? It is completely centralized, which means if these two people are friends of, this person here, and this person, posts anything new on his or her wall, then these people will get the updates. But hold on a second here, Tech. You just mentioned that the client initiates the connection. So how does that happen? I mean, this guy can send a request to the Facebook server and say, okay, oh, I just got out of a class, it was super boring, and I still have marks from the Drew in the class. Okay, so the server comes back and say, okay, that entry is now added to your wall.